Solving systems of equations. We're going to do a 3 by 3, meaning 3 equations, 3 unknowns, and we're going to introduce matrices. We have 3 equations, 3 unknowns. Now, we're going to manipulate these equations. Multiplying any one equation by a constant does not change the solutions. Adding one equation to another equation to create a new equation also does not change any of the solutions. Let's begin, shall we? So the first thing I did was I labeled the top equation, equation 1, and then equation 2 and equation 3, so on. And as we adjust and add them together, we will create new equations, and I will relabel those so we can keep track of what we're doing. So what I did was I'm only going to try and change and get rid of this one, change it to a new one. So I have E1, E2, E3. I rewrote equation 1, it's unchanged. I rewrote equation 2, it's unchanged. I changed equation 3, so I added the first equation to the second equation to get a new equation. That's equation number 4. So my handwriting's bad. In equation number 4, if you add negative x and x, it cancels. If you add negative 5y and positive 5y, they cancel. Negative 5z plus negative z is negative 6z. 2 plus negative 20 is negative 18. Now I can actually solve for z. Now, I didn't change the first equation, so I just rewrote it, equation number 1. Equation number 2 now is going to be manipulated. I'm going to add, take equation 1 and add the negative 1 times equation 2. That's going to be a new equation 5. I had a typo, I fixed that there. So when I do that, I have negative x plus negative 4x, that's negative 5x. Negative 5y plus negative 1 times negative 5. Now this becomes a positive 5, and they cancel, so that it's gone. And I have negative 5z. Oh, I made a typo, it looks like. I just caught an error there. And that should be a negative 9z. Negative 5 plus negative 4 is negative 9. And then 2 plus negative 19 is negative 17. Now we can start solving. So now that I have one equation, one unknown, I solve for z, I get 3. Then in the equation where I have 2 unknowns, I now have z, so I only have one unknown, so I replace z with 3. And I simplify, solve for x, x is negative 2. I have 2 of my unknowns solved, so now I essentially have one equation, equation 1, with only one unknown, and that's y. So I replace x with negative 2, z with 3. I did that here. Then I simplified, combined like terms, and solved for y. Y is negative 3. So the final solution is, in order, negative 2, it's my x, negative 3, it's my y, and 3, that's my z. There's going to be less explanation and more writing on this one, so just pause as you take notes so you can follow along with the steps. I didn't change equation 1 or 2, so I just wrote them in black. I changed equation 3. I added equation 2 to equation 3 to get a new equation, number 4. So when you add these together, you get negative 4x. These cancel, and you get 16. So now I changed equation 2. I needed to cancel out one variable, just not the x. So I have a new equation 5. It's going to be the sum, right, between equation number 1 and the opposite of number 2, meaning I multiply equation 2 by negative 1. So all these signs flip-flop. So I have negative 4x plus 2x now, which is negative 2x. I have negative 5y plus positive 5y. Cancels out, it's gone. And I have negative z plus 2z, this positive z. 18 plus negative 12 is 6. And now we solve. So we take equation 4, and we solve for x. X is negative 4. Then we take equation number... Then we plug in the value of x, in for x in equation number 5, this here. So negative 2 times negative 4, positive 8. We solve for z, z is negative 2. Then we take both of these values and we plug them into our original equation, number 1, which is right there, with the value substituted. Negative 4x minus 5y minus z. So then I replace those values, you get, I see a mistake. Caught my mistake. I made a standard error. I did negative 4 times negative 4. It was negative 16. That's wrong. It's positive. So then I combine like terms, you get negative 5y equals 0, which means y equals 0. So here's our solution. The second mistake was I wrote my y original solution in the z spot. So remember, this is alphabetical order. It's an ordered pair, or in this case, it's an ordered triplet. Okay, this is the coordinates in three-dimensional space, left to right, up to down, up and down, in and out. Okay, and so here's our solution. Negative 4, 0, negative 2. So here's our original example. We're not going to solve because we've already done that. I believe it's our original example. But we're going to write this system as a matrix. And so I'm going to write it out, and then I'm going to define these terms. Here we have an augmented matrix. Okay. It is a way of organizing our data. It's called an array. This is an array where we have rows and columns. And the augmented part means we have the solution here. If we were going to write a coefficient matrix, it would look different. This now is a coefficient matrix. It's just the coefficients of our variables from our system of equations. We still have those same coefficients here. In the augmented matrix, the difference is there's this vertical line, which really represents our equal signs here. And these are the solutions to this equation, or excuse me, the thing on the opposite side of the equal sign, not the solution. I misspoke. Coefficient matrix has just the coefficients. The augmented matrix also shows what is on the other side of the equal sign. Now let's talk about dimension and matrix notation. Sorry about that. For the awkward silence, I thought I paused it. This is a 3x3 matrix. There's 3 rows and 3 columns. Okay, and a 3x3 matrix is determined by the coefficient matrix. So this also would be a 3x3, even though it looks like there's a 4th column. We do not count what is on the right side of the equal sign when we count the dimensions of a matrix. So just move this out of the way. When we name, so matrix notation, when we name a matrix, we use capital letters. So this would be matrix A. If I wanted to talk about the number 5 right here, this would be lowercase a, because we're talking about an individual element inside the matrix, and it's element 3, 2, meaning it's in the 3rd row and it's in the 2nd column. Okay. If I had a matrix B, and we can write the equals on the other side, this element here, let's say it's 1, 2 rows and 1, 2, 3 columns. This element here would be lowercase b, 1, 3, because it's in the 1st row and the 3rd column. So now, I want you to write this as an augmented matrix. Why is this the same one we just did? No, it's different. So go ahead and pause and write it down. Okay. An augmented matrix, remember, hopefully you remembered your vertical line. And then we write the coefficients of the variables in the system of equations. One thing to remember is that these must all be the x variables. These must all be the y's and the z's. Or if I was using ABC, if this was A, B, C, these must all be the a's, the b's, and the c's. No matter what the variable is, these must be vertically aligned so your matrix makes sense. And then we have what is to the right of the equal sign. So this is our augmented matrix. Done.